I know we went over number 25 in class, but I wanted to provide a video in case you missed something. Number 29, we're given y prime. We're asked to find when f has a max or a min, or where f has inflection points. And keep in mind, I use f and y interchangeably. So when I say f prime, I mean y prime, and if I say y prime, I mean f prime, and so forth. So I apologize, my brain just works like that. I hope it doesn't mess anybody up. If it does, complain and I'll try to fix it. I don't mind that complaint. I don't want to confuse you guys. So given y prime, we can easily find the critical points for y prime, meaning where y prime is equal to 0. We can see that because it's already factored that y prime equals 0 when x is equal to 1 and when x is equal to 2. We conduct our y prime test and to determine the sign of y prime. So we make a sign chart, put 1 and 2 down here on the axis, and then determine what the sign of y prime is to the left of 1. And we can see that when x is when x is less than 1, we see that y prime is less than 0. So therefore y then would be decreasing. In between 1 and 2, we see that y prime is again less than 0. So we have that information about y then again, that y is decreasing. And then to the right of 2, for all x values greater than 2, we see that y prime is going to be positive. So therefore y is increasing. So we have that. We have decreasing, decreasing, and then increasing. So therefore, at that critical point of 1, I like this example because it shows you that at that critical point of 1, we don't have a max nor do we have a min. Okay, when you go decreasing, decreasing, you don't have a max or a min. However, when f goes from decreasing to increasing at 2, we see we have a minimum value. Okay, in fact, that's an absolute min. It's not just a local min, it's an absolute min. And knowing what we know about y prime being to the third power, so y prime being a third degree polynomial, we know third degree polynomials go up from left to right when the leading term is positive. And so knowing that about y prime would help us understand that y double prime that y must be a fourth degree polynomial, that it has to have the ends of the graph going up in the same direction. And so that's indicated by this graph that I drew down here. So just a rough sketch of what the graph of y would look like. It would be like this, decreasing till we hit the first critical point, and then decreasing again till we hit the next critical point, and then increasing. Okay. The y double prime part will tell us what the shape of the graph is, meaning concave up or concave down. So let me get rid of some of this stuff that I just drew. Alright, so we have our absolute min. Now we just need to figure out what y double prime is and to determine the concavity and where we might have inflection points. Okay, we can see though, just from knowing what we know about the shapes of polynomials, that we should have, well, we will have an inflection point here at x equals 1. That's where I indicated this here. And then there's some change of inflection in the graph of y right in between these two critical points, because we're decreasing, decreasing, and then increasing, and we know that polynomials are nice and smooth, so we must have a change in concavity somewhere in there. And we can't just assume it's at 1.5, so let's take a look. Y double prime, I use the product rule to find y double prime. First times the derivative of the second plus the second times the derivative of the first. So check that out if that's something that had bothered you. I'm going to erase a little bit of this sign chart over here just so I can clear some space. Alright, and then the hardest part to understand, I guess, the hardest part I guess in this whole problem, I have found that students find that factoring this polynomial here for y double prime presents its greatest challenge. So y double prime though, if we factor out an x minus 1, we're going to get x minus 1 times, and then what we have for our first factor is x minus 1 plus 2 times x minus 2. Okay? And then keeping that x minus 1 factor out there and combining like terms inside the brackets, we get 3x, and then minus 2 minus 4 is minus 5. Okay, there are other ways to do this, but this is the way I like to do it. It saves me time. But again, I find that sometimes students really just have a tough time seeing that. Okay, but as soon as you see it, it's pretty easy. But I challenge you to try to work this out so that you understand. So we see that the two critical points for f or y double prime are 1 and 5/3. In other words, when x equals 1, y double prime is 0. And when x equals 5/3, y double prime is 0. I'm not going to bore you with the details on how we got that, but basically you set each factor equal to 0. Now, to the left of 1, we see that y double prime, and when you plug in any value to the left of 1, let's just plug in 0. If you plug in 0 here and 0 here, we get -1 times -5, so we get positive. Okay? Oh, I should have done this. Plug in 0 there and 0 there, we get positive here. Now, if we plug in, what does 2? No, 2 is too big. I guess let's just plug in a big number like 10. So if we plug in 10 here and 10 here, we get 9 times a big number, so we get positive. Okay, and you just have to trust me here that that when you plug in a number in between 1 and 5/3, the y double prime is going to be negative. But you can check it out. Just find I don't want to take the time right now to do that. But if you were to take the time to do that, you would see that y double prime is negative on that interval. And therefore we see we have a change in concavity at 1, a change in concavity at 5/3. So these guys right here are where f, or y, has an inflection point. So these are the inflection points when x is equal to these values. They're not actually the points, they're the x coordinates or the x values in which y has a point of inflection. Okay, you can easily find the y values if, well actually, sorry, I take it back. For this problem, you can't find the y values because you don't have y, you just have y prime, and you'll learn how to find y given y prime next year, so you don't have to worry about that now. Alright, so that's it for number 29. The next video, hopefully I'll finish all the rest of the explanations for that homework assignment.